Hi everyone, it's pleasure to be here in front of you all. So the topic I'm going to talk about is called the policies the protocol. So before we deep dive into the detail, let's think through this. I guess most of the teams out here have been fed with the same thought that the following three things cannot coexist. So what I'm referring to is an AI system to be compliant, capable as well as an offline resilient. But through this talk I would like to tell that this is something not the case and all three things can coexist, and that too as a part of a single architectural decision to be made at once. Hi, this is Akhil Gupta, and I want to present a prototype. A prototype is an AI assistant application deployed on mobile phone and something applicable for any memory constrained device. It's being developed using the frontier class models and has an MCP plane in place, completely working offline in the mobile phone itself. No data being shared across the network, and there is no token cost associated for the inference. Now, before we deep dive on the architecture that we are presenting here, we need to understand like why the data privacy or the governance compliance is something not a luxury. It's not a good to have thing. It's an obligation. As we understand the India DPDP Act and the GDPR policies, with an enforcement teeth of around a decade now, it's already in place. And moreover, if we are from the background or from the domain to be a financial or healthcare, we have our own domain specific mandates on top of the governance stack. So we need to be compliant with all of them. The point is like when we talk about data privacy, it's not just about to ensure that the data is safe, but it's more about to ensure that data doesn't leave the jurisdiction, and moreover, any autonomous decision being taken is auditable. Now, most of the AI system, when we talk about follow a pattern wherein a user writes a prompt, it gets serialized and gets saved over an endpoint specified to the cloud. And what brings in a challenge with the auditability for the same. But I'll tell that's not the only one. It basically comes with the three other costs. The three costs associated with this pattern can be classified as follows. The very first one is whenever we make a call over the network, our query gets associated with the token and hence is chargeable. So basically, it's quantifiable, and there is a round trip associated with the cloud. So that brings in the latency, and that is something measurable. And eventually, something that breaks the system in the production is when the system we are working on rely on a network that is not a trustworthy at all. So that brings our system completely at a jeopardy, and probably the system doesn't take off. Now think of the scenarios wherein suppose a nurse is doing an emergency operation in the basement, assuming there's no network signal coming in, or an engineer working in the offline refinery, oil refinery with no signal, and the defense system which doesn't have a privilege to have an TCP handshake. What happens in that case if we follow this architecture? In that case, we even if we are sharing the data over the network, it doesn't turn out to be only a technical glitch, but it's more about like the compliance breach, because this is something API data that shouldn't be shared across the outside the boundaries. What exactly we are talking about is what if we bring in a single solution for both, a system to be capable as well as compliant. So what we are bringing in an architecture here wherein we are using MCP. We are leveraging MCP not only for tool calling at the AI edge devices, but as a MCP as a protocol that turns out to be a single choke point that defines whether which all AI model to be called and which tool are being permitted to be called, and eventually how the governance to be implemented across the pipeline. That too completely offline as a single pipeline in a device itself without any data being sent outside the device or touching the air at all. Now, if you look at the slide, here on the thesis is being corroborated by this pipeline, where we see the UI is something where we get the request, and it's basically it's comprises of the 5 Kotlin files that takes the data from the user, and that parameter of the payload is being sent to the MCP client, by which has an implementation of a JWT token defined per scope and eventually being sent to the MCP server. Here it looks like as a standard practice, but the crux here is the data being sent over to the MCP server is not over the network or any socket layer, but it's completely a coroutine, a method call, or you can think of a class in the same application without sending any data outside. So the whole pipeline, starting from the security layer where we have the guardrails defined, followed by IAM authentication, IAM service, the triaging or the governance based on the LLM's confidence layer or inference. Everything goes as a single pipeline but completely offline. And if you summarize, what we can say that we are using MCP, but we are just returning the protocol but deleting the network. Okay, so it looks fair enough, but what exactly we are achieving out here? So we are bringing in the capability as well as the compliance. So in terms of capability, the thing is we are using frontier AI models with full MCP orchestration in process and doing the real inference with no API key or the call over the network, and hence no cloud bill. The other thing we achieve is the compliance hub, because since there is no data ingress, means we are not sending data outside, so it doesn't turn out to be a checkpoint in the policy document, but structurally we are guaranteeing no data going outside the device, so hence it's compliance with the GDPR provisions. So it becomes a structural guarantee. That's the reason why I call it like it's a architectural property, but not something that's defined as a policy. So what exactly, how we are going to attain this? The core idea here is the control plane. As I just said, we are going to keep the protocol and delete the server out here. And how do we bifurcate, that we'll be talking in the next slides. But before that, I need to tell what the moat here, what exactly bringing in this capability. So the execute torch is a lightweight runtime engine for AI models that makes it feasible to run model on the memory constrained devices. And it comes with the 4 support layers. So what exactly we are talking about is execute torch has a native PyTorch support for an export. It means the whole computational graph that turns out to be for the model get directly mapped to the backend accelerator without needing any separate inference engine. Moreover, irrespective of the model, be it 5.3 model or the Whisper model, we get one PT artifact, and that is something that would be running on the inference engine. Secondly, the int4 quantization using the static compile time static memory allocation, we ensure that the 5.3 model gets quantized as good as to 2 GB of RAM. That can be easily fit into the mobile, and the compile time the compile time static memory allocation ensure that the garbage collection doesn't interfere at the inference, so address the latency or hiccups as well. Thirdly, the Qualcomm HTTP delegation. So what it says, like, you can directly lower the graph, map it directly to the hexagon NPU, fast and powerful when compared to CPU, and even the fallback mechanism across the hardware would support it. So there's no code change as such. And mostly the last one that improves the use and privately is something because it comes up with the provision of testing API. The fidelity testing API ensure that the data get fine grained, get tuned using the same inference engine, and since we need not to send the data outside even for the training, so it brings down the liability, or basically it's bring the liability of data privacy to zero. So what we intend to say, whatever runtime engine for mobile we see, even if by Microsoft ONX runtime, none of them support all these four features together. That's quantization to give a native model export support, or the STTP or the STP, sorry, the STP delegation, or the training model API. So as we just discussed, how the security and governance that comes into the picture. So governance we can bring in a mode of having a two toll gates. The gate one, that something talks about, yeah, gate one, that something that blocks the jailbreak PI data and safely flags. If it fails, it gets closed. We are using SHA-26 for auditing, so that we need not to log the raw data. Secondly, if the gate one passes, gate two comes into the picture, and it tells a different question, whether the user is, even though he is eligible, but, or whether the user is has an access but to the system query is correct, but does he has a provision to access the particular tool. So there is a scope check against the key sealed in the secured hardware. Basically, we define the role at the runtime for the agents with the basic with the basic access we have given for the SLM and for the knowledge read, and elevated for the LLM, and system level access we are providing for the system, for the phone sensors and all. Not, if you look at the right side of the slide, we see here we are bringing zero point 0.7 route decision. So it's basically every time the call comes to the to the SLM, most of the time we can count it at a figure around 80%. I'm just throwing a number out here, but mostly call will go to SLM. SLM will address that. If the logistic distribution says that the response is beyond zero point 0.7, it will go for argumentation using the fast indexing, using the FIRE model, and augmented using RAG, it will give you the response. Otherwise, it eventually it goes to large model that is held at reserve. So one note here is like SLM and RAG confidence is real, but logistics that for the large language model is a placeholder today. Now, if you talk about the devices, so this on-stack device that we are just talking about is a production proven. The Raven Meta class is already using the executorch. Similarly, Apple and Google are already into this picture along with the NPU, along with the Qualcomm. So we are not bringing in something new, but we are using the same architecture, but we are telling how we can ensure the compliance and data governance on top of that using MCP. So EdgeMind is something combination of 5.3 model info quantization along with execute torch and Qualcomm HTTP combination that ensures there is no cloud access egress. Not talking about why it is something we can generalize. Well, this could be generalized because the demo that we are going to show it something confined to the medical domain, but it doesn't know anything about the clinical triaging. The point is the same application can be reused for any other vertical that we want to ship with. The only thing we need to swap just the three file. That's the corpus file that's having the domain knowledge along with the vector index and the fine tuning the weights. That's the model PT file. Rest of the thing remains same. MCP orchestration, security stack, inference runtime, or the federated loop. This is something for now. For illustration, I say we can extrapolate it to the different layers with logistic, pharma, oil, gas, or emergency, or bit for sales. If we see for sales for Einstein has already leveraged that. License has been displaced per 500 representatives. Pharma representative also get the license for same, and same with the logistic cloud token. If you see the logistic cloud token, we can save a lot on that. We can bring that cost to as good as to zero. So my point is for any engineer or the team lead or architect, whoever want to bring in this, they can simply need to bring in their knowledge base and we'll bring the governance. Now I need to set about the state that what exactly is in the production today. What is the production ready? It's like there's no server, no transport. It's in process MCP along with SLM rare confidence routing from the logics and offline signed audit log. However, what's on the path is the keystore backed audit log and Gamma 2 support. So the point to tell here is these are the engineering gaps, but not something that's not cannot be built, and this can be hardened. So we are on the way; it can be achieved. So I would like to conclude the talk, but before that, I need to give a quick demo. How how does it actually look? The quick demo. So here we go. Okay, we'll do one thing. We can use another link here. So that would be, yeah, we can go use this one. Yeah, so we can simply use this to walk through the demo.